problem 1. And this is the first part in our ships on water series. So we've learned about this actually in some of the other videos. And there was actually another playlist called Ships and Water Problems, and that is the 4th grade Math Olympiad level for this. So I'll be putting that playlist link in the description down below in case you want to look at it. And that's going to cover some of the basic information we need for this type of problem. And I believe there's going to be a lesson for it that teaches about the main elements needed for ships and water problems. So this is problem 1. And if this is your first time and you're a beginner to this, don't be afraid to go down to the description and take a look. All right, so let me first read this problem. Harbors A and B are 360 kilometers away from each other. A ship takes 35 hours to go from A to B. Traveling upstream took 5 more hours than traveling downstream. Now another ship travels from harbor A to harbor B and back, traveling at a ship speed of 12 kilometers per hour. How long will it take for the second ship to travel from A to B and back? All right, so the first step is to draw what I would call the E diagram. So what this is, so right here, we have a very tall E. And up here, this is going to be the water speed. So speed of the water, velocity of the water. And we're going to write it somewhere here. This is going to be ship speed. This is going to be upstream speed. And, well, this would be upstream speed. I feel like that makes more sense. And this would be downstream speed. But right now we have 2 ships. So what are we exactly dealing with here? All right, so this is going to be ship number 1. Like I'll say, because we have more information about ship number 1 than 2. Okay, so what we need to know is we need to know the water speed in order to, because this is the second ship now. We need to find the water speed, right? Okay, so let's first try to find the ship speed over here. So we know that they are 360 kilometers away from each other. They're 2 harbors. And in all, the ship took 35 hours to go from A to B. But traveling upstream took 5 more hours than traveling downstream. So x plus 5 is equal to 35. 35 hours, and x is going to be the amount of hours took to go downstream. So this would be 2x equal to 30. So x is equal to 15, and x represents the amount of hours ship 1 took to go downstream, meaning that the ship speed, that its downstream speed is going to be 360 divided by 15. All right, so 300 divided by 15 is 20, and 60 divided by 15 is 4, so 20 plus 4 is 24, meaning that the downstream speed of ship 1, the downstream speed of ship 1 was 24 kilometers per hour. Okay, so now that we know that, we can easily find out the upstream speed, right? Because we know that in all it took, we know that $360 divided by 24, right? 15. So it took 15 hours to travel downstream. And in all, it was 35 hours. So it took 20 hours to go upstream. 20 hours to go upstream. So 360 divided by 20 to find the speed, right? We have 18. So upstream speed of ship 1 is 18 kilometers per hour. Now we're going to find the velocity of the ship itself in still water. So when we do this, we're just trying to find the middle number between 24 and 18, because we know that this is equal to the ship minus the water speed, and this is equal to the ship plus the water speed. So since the water speed doesn't change, at least we're not told it changes, we're just trying to find the middle number between 18 and 24. So that would be 21 kilometers per hour, because 24 is 3 away from 21, 18 is also 3 away from 21. Meaning that the speed of the water is 3 kilometers per hour. So that's what we're looking for. So now we know the ship speed, and we also know now we know the water speed, and we also know the ship speed of ship 2, because it's 12 kilometers per hour. It says it right here in the problem. So we're just trying to find the separate times for ship 2 to go upstream and downstream. So first we're going to have 360 divided by 12 plus 3. So 12 plus 3 is 15, right? And 15 divided by and being divided into 360, that's 24. So it took 24 hours right here. And then we have another 360. Now we're going back, and it's 12 minus 3 because we're going upstream, so it's harder now. 12 minus 3 is 9. 360 minus 9 is 40, so 40 hours. Now we add these 2 hours together and we get 64 hours, meaning that in all it took the second ship 64 hours to get from A to B and back.